Hello students, welcome to the class. Today we are going to start with a new chapter known as Semiconductor Physics or sometimes called as Semiconductor Electronics. This is a very interesting chapter and it is quite different from the other chapters in physics which we have studied till date. Okay, what does semiconductor deals with? Okay, look around yourself. You will be surrounded with only semiconductor. When I say with the word semiconductor, it means the electronic devices, your laptop, your phone, your television, your radio, anything around yourself which is electronic is made up of semiconductor. So this is what we are going to discuss. We are going to get inside the semiconductor and see what is p-n junction diode, what is Zener diode, all those things we are going to study in details. So to start the introduction of the chapter, the first thing is what semiconductor is made up of. Semiconductor are made up of those elements which has got valence electrons 4. As for example, I'll take silicon. Silicon is the most abundant element we have to make semiconductor. We can take germanium as well if you want to, but its valence electron should be 4. There are some compound semiconductor also we can take, as for example gallium arsenide. But here we will be dealing with silicon only. While making LED, light emitting diode, we will take gallium arsenide. So it's all about electronic devices. Earlier people used to use called as vacuum tubes. Vacuum tube is a device which is also made up of semiconductor. So vacuum diode, vacuum triode, all those things used to be in use. So let us discuss the semiconductor chapter nicely. So students, now we will be starting with the main thing of the chapter. Before going to the semiconductor, let me ask you one thing. What materials are made up of? If you want to classify the material, how we are going to classify it? We say
Materials can be classified.
in insulator, in metal and in semiconductor. In this 3 ways we can classify it. Okay. So based on their resistivity and conductivity, how they are divided, we are going to study in this topic, and also in the later topic we are going to see how they are divided in terms of energy band diagrams. So let us see first in terms of resistivity and conductivity. I will take first metal. Suppose if you see on the screen, the range of resistivity is given and the range of conductivity is also given. So which is just the conductivity is just the inverse of resistivity, right? So metal has got a very high conductivity. And why resistivity is less? Because in metals the resistance is less. The electron can flow very nicely, right? That's why the resistivity is less. As we know, resistance is directly proportional to what? Resistivity. That's why it is less. Then we move to semiconductor. So resistivity is lying some in mid range and conductivity is also lying some mid range, which is shown in the screen. And if you go to insulator, you will see that the resistivity of the insulator is quite high, it is very high, whereas if you take its conductivity, it is very less. I mean very less in the sense quite less. So what I am trying to tell you is that if the resistivity is more, therefore the flow of electron will not be that much efficient. Therefore in insulator we have high resistivity and low conductivity. So this is how we can classify insulator, then metals and what semiconductor in terms of their resistivity and conductivity. My dear students, we are going to start semiconductor, but before that we are going to see energy band diagrams also. So take care of this part nicely. This is just, I can say, includes the introduction part also, but this is the first topic of the chapter in your NCERT book. Now students, we are going to do classification of materials on the basis of the band diagrams. Like last time we have seen the classification of materials on their resistivity and conductor. Here we are going to see on the basis of their band diagrams. Okay. Now let us see first insulator. We have 2 bands, that is conduction band and valence band. What I am trying to say is that in any material there are 2 bands are possible. Keep as simple as possible. How many bands are possible? 2 bands, that is conduction band and valence band. Okay. Valence band are completely filled and conduction band sometimes are partially filled. So in case of insulator, the gap between the valence band and the conduction band is very high. Therefore, with the supply of energy those electrons from the valence band cannot jump to the conduction band. That is why no electricity or no conduction is possible in insulator. That is why we call this one as insulator. Without any current, they go on. Only it is possible when the electron will jump from valence band to the conduction band, then only the conduction is possible. Keep it in your brain. Now take the example of semiconductor. Now the gap between the valence band and the conduction band is in mid range. Therefore, if you supply external energy in the form of heat, maybe in the form of voltage, fine, then the electron from the valence band can go to the what? Conduction band, and therefore the current is possible and the conduction current is possible. That gap, actually we call this one as energy gap and abbreviated as EG also. Okay, the energy which you are supplying from outside, that is your external energy, has to be greater than that of the band gap's energy. We call this one as band gap also. Fine. Now, if you take the example of what? The last one, that is metal. What you will see, in case of metal, the valence band is overlapping with the conduction band. When the valence band overlaps with the conduction band, there is no worry at all. Electron can easily go to the what? Conduction band, and the current is possible. That is why conductors are generally used for conduction of current. At your home, the wirings are made up of what? Copper wire. Copper wire is a what? Metal, right? So in case of metal, it is not that tough. It is quite easy for the electron from the valence band to go to the conduction band, and current is possible. But mind it, in case of semiconductor, we do have to supply external energy. That is what we are going to study in details in this chapter. Okay. Now my dear, let me start with semiconductor. There are how many types of semiconductor? There are two types of semiconductor. One is called as intrinsic semiconductor, the other one is called as extrinsic semiconductor. So let me start with the first type first, that is intrinsic semiconductor. Intrinsic means pure form. The purest form of semiconductor is called as intrinsic semiconductor. Now, if you look at the screen, you will see that semiconductors are forming covalent bonds with each other, and the resulting structure of the crystal is a semiconductor. Okay. So all the 4 electrons of the semiconductor are sharing covalent bond. You take the case of silicon, you take the case of germanium. Okay. All the 4 electrons will share what? Covalent bond with the other atoms present in that particular element, particular system, you can say. Fine. Now, the cases, in case of intrinsic semiconductor, there is no foreign particles added to it. We say there is no doping. Remember the word doping, I will make you understand in extrinsic semiconductor. So since there is no doping, no addition of impurities, then this type of semiconductors are called as intrinsic semiconductor. Okay, let me go to the second type of semiconductor, that is called as extrinsic semiconductor. I will say the impure form. You have a semiconductor, you are adding something to it. Adding means you are adding impurity to it. Now, why do you need to add impurity to a semiconductor? In order to increase its conductivity. As for example, doping is done on a pure form of semiconductor, and the doping is called as the process of adding impurity to the what? Pure semiconductor. Based on the doping, there are 2 types of extrinsic semiconductor, fine, and these 2 types are called as N-type semiconductor and P-type semiconductor. In case of N-type semiconductor, it will be doped with pentavalent atom. What atom? Pentavalent, having 5 valence electron, as for example phosphorus. So if you dope a silicon with phosphorus, silicon has got how many valence electron? 4, and phosphorus has got 5 valence electron. So 4 of them will share covalent bond with each other, and the left on one extra electron will be left. Okay. That extra electron actually takes part in conductivity. The name N-type means negative type, electrons being negatively charged. So therefore, there will be lot of negative charges present in the whole element. Okay. So what I am trying to say, extra electrons are called as n-type semiconductor or negative type semiconductor. There is something else also present there. Okay, I will tell you in p-type that one what is there is something new you will learn here. So in short, in n-type we have extra electron, more number of negative charges, and it has to be doped with any pentavalent atom. Okay, now let me go to p-type semiconductor. When a pure semiconductor is doped with trivalent atom, as for example, aluminum being doped with what? Aluminum is not doped, actually silicon is doped with aluminum. So what you will see? Out of 4 electrons of the silicon, 3 of them will share with aluminum, right? But aluminum one space will be vacant there. That absence of electrons which is vacant in the case of aluminum is called as hole. What is the word? Hole. So in semiconductor, not in electron takes parts in conductivity, there are holes also which take parts in conductivity. So what I can say here is, in p-type semiconductor there are a lot of holes present, holes being positively charged, therefore it is named as positive type semiconductor. So the majority carriers in p-type semiconductor are holes and minority carriers are electron. Minority means very few electrons might be there. So in case of n-type, majority carriers are electrons and few more holes will be there, that will be called as minority carriers. Now my dear, as we know n-type semiconductor, as we know p-type semiconductor, we also need to make their what? Band diagrams. So let me start with the band diagram of n-type semiconductor. Now if you look at the screen, in n-type semiconductor, just below the conduction band there is a level known as donor level. What level? Donor level, where electrons can be donated. In n-type semiconductor you have seen the electrons can be added. So just below the conduction level, a level will be added where those extra electrons will reside, and it will be very easy for those extra electrons to go to the conduction band and take part in conduction. The gap between the conduction band and the donor level is very less, so the energy required to put that electron in the conduction band will be less too. So that is how we can make the band diagram of n-type semiconductor. Now if you want to make p-type semiconductor, that can also be made. How you are going to do in case of p-type semiconductor? It will be just the opposite of n-type, right? So in place of this valence band, just above the valence band there will be another level where extra holes will be residing in case of p-type. So an energy has to be supplied, little energy. Those electrons from the valence band can easily go and mix with the hole, and there will be lot of holes present in the valence band. So you can make this diagram by yourself, as I have shown you the diagram of n-type semiconductor. So p-type can be done by you. So an important topic from the chapter is done, where I told you types of semiconductor, that is intrinsic and extrinsic. I told you types of extrinsic semiconductor, n-type, p-type. N-type, negative type, more electrons, pentavalent. Fine. P-type, positive type, more holes, okay, doped with what? Trivalent atom. And finally we have seen the band diagrams.